Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston, we don't have a problem. Today we want to talk about how to solve problems dimensionally. So we learned in the last video about how to do what dimensions are. We talked about time and distance, time, distance, and mass. And but you can solve problems with dimensions. So let me give you kind of a sort of an important, sort of famous equation. Probably the most famous equation in the history of the world was Einstein's E equals mc squared, where c is the speed of light. So the question I want to ask here is, what are the SI units of energy? Energy and then mass, speed of light. So I would say this equals, what's the base unit of mass? It's a kilogram, right? We learned that in the last video. And c is the speed of light. Now speed, if you recall, is velocity, is distance over time, but this is squared. So distance would be meters per second. We're squaring it, so times meter per second. So this is equal to a kilogram, I'm not just simplifying, meters squared over second squared. And that is the base unit for energy. By the way, that has a special name. In the world of science, we give special names to certain things, and that is a joule, J-O-U-L-E, abbreviated with a capital J. You could say somebody has so many joules. Now, when we talk about eating food, we talk about eating calories, but if you lived anywhere else in the world, you'd say it has this many kilojoules in a candy bar or some thing like that. Another famous equation called the Boltzmann equation is E equals H times a funny looking V. This is actually the symbol for something called frequency. Now, when you listen to the radio or your cell phone, it uses a frequency of light, of microwave radiation that, Anyways, frequency is a unit of its waves, because it measures waves per second. Now, you don't actually count the waves, so it's actually just 1 over seconds. And so the question I'd ask you is, what would be the units on H? What would be the SI units for H? Now, we did E just a minute ago, right? The E, or energy, is always a kilogram meters squared per second squared. And that's equal to this funny thing called H, which we're going to solve for in a minute, times the frequency, which is 1 over seconds. S is just seconds. So what would be the units of H? So the question is, what units would H have to have? So basically, 1 over seconds times what equals kilogram meters per second squared. That's what we're trying to find. Well, all we have is an S here and an S here, so it's going to be everything over here minus an S, so to speak. So, because what would H have to be, so that these are two equivalent statements algebraically, it'd be a kilogram meters squared per second. Right? This is H. And I've got them backwards now. There's mu, it's called mu, by the way. Mu and H. And now these are two equivalent statements from a dimensional perspective. By the way, sometimes we might write it like this. We could say kilogram meter S minus 2. If I want to do it all in one line, or S minus 1, it's just S minus 1, because that's to the, this is S minus 2, because it's squared. You go to the negative 1 power is how you would do that. So some of these problems can be a little tricky, but it's not terrible. Let's do one more. Another famous equation is this one right here, P equals mv. And so P stands for momentum. So what would be the units on momentum? M is mass, V is velocity. So that's going to be what? M is kilogram. Velocity is meter per second. So it's just a kilogram meter per second, or we could say a kilogram meter second minus 1. That's the same thing. So the unit on momentum, this is why, by the way, if you are in a car accident, momentum carries you, right? And the bigger the car, the more massive the car, and the faster it's traveling, the more momentum it has, the more difficult it is to stop it. That's why you want to not be hit by a big car, or let's say you're a football player, you don't get hit by that big person, or also it's a function of also how fast they're traveling, which is another ball game altogether. So that's how we do these types of problems. So Houston, we don't have a problem, do we?